The last of our rules here is the quotient rule, and that's for functions of the form y equals f of x over g of x. Okay, so the product rule was for functions that look like y equals f of x times g of x. The chain rule was for functions of f of g of x, and the quotient rule, is for functions of the form y equals f over g. Okay, so this method enables you to deal with expressions that are fractions with variables, functions in the top and bottom. And there's the rule for it, straight out. If you've got a function that you can express as f of x over g of x, then the derivative of this whole function is g of x times f dash of x, take g dash of x times f of x over g of x squared. Okay, so that's the rule you have to remember. We're not going to prove it at this level. Might do that next year. Okay, so the order of terms in the top is important. Okay, so you must keep an eye, remember the order because of this negative sign. Okay, it starts off with g of x times f dash, take g dash f of x. Okay, because of that minus sign makes the order important, whereas with the product rule, the order wasn't important. Okay, the quotient rule only when the fraction cannot be simplified. Okay, so let's just have a look at an example. Hopefully they're going to give us an example here. Oh, okay, there's the quotient rule. Which of the ones would you need? Okay, so this one, yes, you would. I would use the quotient rule. F would be x squared take 1 and g would be x. You could divide this out, and that's what they're probably going to do. So they reckon no need for it, but I would certainly, you could do it. What they're going to do, yeah, they're going to be broken into that. You could really go either way with that one. Let's try the next one. The next one, no, I'd use the quotient rule for sure. You can't simplify that at all. This one, well, you can, because x squared take 9, that's a difference of 2 squares. And you can write that a little bit differently. So, okay, the whole thing is just equal to x take 3, which differentiates to 1, okay? So that top can be factorised to x plus 3 times x minus 3, and the x plus 3 is cancelled. And this one, I would still use the quotient rule for that one as well. They're probably saying to go, no, they say it is necessary. Okay, that's good. Let's try and see what their example looks like. They're going to differentiate this using the quotient rule. So they're going to make f equals x squared minus 1, g equals x plus 2. I think that's what they're going to do. Okay, set out your component parts as follows. There you go. F is x squared minus 1. And therefore f dash is 2x. We get that from our previous rules. G is x plus 2, therefore g dash is 1. So dy by dx of this entire function is going to be g, which is him, times f dash, which is him, take g dash, which is him, times f, which is him, over g squared, which is that one there squared. And that's going to come to all of that, and that simplifies down to that. Okay, and have a go at that and make sure you get that yourself. Okay, let's just try another example. Going to differentiate that using the quotient rule. So here they're going to set it up for us. F of x equals x, therefore f dash is 1. This is g of x down here. So g of x, g equals x plus 1, g dash equals 1. And using our formula as before, dy by dx equals that, and that's going to simplify down to there. Okay. Let's just try one more example. We're going to differentiate this one. That's got square roots in it. So once again, f is going to be root x, g is going to be root x plus 1. So let's see how they set this out. There you go. F of x equals root x, therefore f dash is 1 on root 2x. Okay, that's just from another PowerPoint. So g is root x plus 1. So g dash is 1 over root 2, so 2 times root x plus 1. This is actually using the chain rule we used here. which we get from another slide, another video. So using our formula, it all comes out that pretty messy, but there's our G here. Okay, there's our F dash, which is there. Take, and then this here is G dash, and there's our F, all over G squared. Now, if you square root if you square a square root, you just get the x plus 1 there. Okay, and that probably simplifies down to, what do they reckon? You can work on this to just simplify this. Okay, this isn't a big deal. Just simplifying a third. Let's see what they finally get it out to. They're giving them pain in the neck. There you go. It simplifies out to that. Okay, that's all we're going to do for the quotient rule. You get the basic idea, and that's the last of our rules. So we've got the quotient rule, product rule, the chain rule, and we also have the rule for differentiating a polynomial ax to the n minus 1. And that's as far as we need this. We might come back and have a look at the trig functions, what their derivatives are, but that'll be in another slide, in another video, sorry.